Hypothalamus artificial intelligence, HI. Digital transformation powered by real-time autonomous and intelligent algorithms. Presence. The integration of OPTEX, Optimization Expert System, IBM PLANNIG Optimization Studio, and IBM PLANNIG Analytics. Case. Integrated business planning in the beer supply chain. HI operates as a knowledge factory in highly complex mathematical modeling. Its main interest is the monetization of its intellectual property, making win-win commercial alliances. For this reason, one of HI's main interests is to make joint ventures, with IBM Business Partners, and with IBM wholesalers to go to market. The solutions offered by HI can support the growth of startups, spin-off companies or already consolidated companies, to offer solutions to their end users, as part of the digital transformation of companies. Link OPTEX to IBM Planning Analytics. OPTEX's multi-problem model capability implies that the union of mathematical programming problems generates a new model, or a variation of an existing model. In this case, two models are formulated. SANDOP, Sales and Operations Planning, and ALM, Assets Liabilities Management, which is geared towards global supply chains. Implementation of integrated business planning beer supply chain using OPTEX. Making complex models as a Lego game. The expert optimization system is supported by the artificial hippocampus, which stores structures and processes for scientific decision-making that must be permanently consulted. It stores, like in humans, the experience and the knowledge acquired over time. In the case of model formulation, a modeler should not repeat work every time he modifies a model. The joining, or splitting, of the models is done by keeping the records in tables. That is, in practice, formulating a problem is selecting, by clicking, the equations that compose it, in the same way models are formulated, as if they were a Lego model, which are formed by a set of equations, the Lego pieces. After OPTEX's first deployment, the expert system was extended to store the history of all executions of a model, so that this information is used to perform hot starts of the models, accelerating the solution time. Initially, the OPTEX user interface was a data window to capture the contents of tables. The screenshot presents the master table of indexes, and all the tables with relationships with other entities, like variables, constraints, parameters, aliases, problems, data tables, and fields in the data tables. This vision implies thinking outside the box, since the relationships between mathematical elements are not investigated in the computer programs, but they are visualized in a holistic way through the exploration of a database. This input-output interface is generated online by OPTEX, which means that there is not a program associated with the windows, menu, shell and data, and their connectivity. OPTEX, as an artificial intelligence, interprets what is stored in databases, and generates a hologram adjusted to the application. As an output interface it is still valid, due to the organization and ease of handling of any SQL database. Today the data is captured directly from MS Word, and soon it will be from ChatGPT. The fundamental elements of the OPTEX architecture are a relational information system, which integrates two specialized information systems, Mathematical Modeling Information System, MMIS, stores the entire mathematical modeling environment, and Industrial Data Information System, IDIS, stores customer data. The next element is OPTEX, the generative artificial intelligence in charge of interpreting the existing information in the MES, and from there generating all the computer elements that are required for the user to interact with the DSS. Based on Open Database Connectivity, ODBC, OPTEX generates the following elements: visual interface for the user to access the IDIS to maintain and consult it. Interface for mathematical models to connect with the IDIS, generated following the syntax of each optimization technology. This interface is part of the computer programs of the algorithms. Below are several examples of this type of component, based on SQL statements. To learn more about OPTEX, those interested can watch the video, Not Programming, the Dream of Every Programmer. Industrial Information System. If the modeler wishes, OPTEX automatically generates the Industrial Information System, to store the input and output data to the mathematical models. To store the input and output data to the mathematical models. OPTEX manages a metadata model that, automatically, generates a user interface that includes an Explorer menu to navigate the tables of the IDAS that can be resident on various types of database servers. Second, all the shell windows that contain the master and the relations tables for each entity. These components, browser menus and windows, are not associated with any program. They are generated by OPTEX, online, when the user requires them. The screenshot presents the master brewery table, and all the tables related to that entity. The screenshot presents the packaging plants table, and all the tables related. To store all the results of the runs of the models, OPTEX automatically generates the structure of an extended information system, based on the scenario and scenario families concepts. Regardless of the programming languages, the models connect directly to the IDAS database, by means of SQL statements. The screenshot presents SQL connectivity and an IBM OPL program. Because the IDAS data model is open, the end user can connect it to any other application developed by a third party, this for any input-output data. OPTEX, Optimization Expert Systems and IBM PLANNIG Optimization Studio. This section introduces the IBM OPL program generated by OPTEX. It is presented in parts, indicating in each case the content of the partial image. IBM PLANNIG Optimization Studio. It is an IBM product, especially oriented for the implementation of prescriptive analytics solutions, which integrates three types of products. First, optimization engines, mathematical problem solvers, include two types of algorithms. PLEX optimizers, algorithms aimed at solving mathematical programming problems, and PLEX CP optimizer, algorithm based on constraint programming. Second, model development tools. It is composed of OPL, IBM Optimization Programming Language, an algebraic language for programming mathematical model algorithms, and Concert Technologies, object libraries for programming mathematical models using general-purpose languages, such as C, Python, Java, and others. Third, ODM Enterprise. Specialized interface for handling runs of mathematical models, and visualization of model results. It integrates three types of IT solutions: user interface, optimization model server, and data server, input and output, of mathematical models. There are multiple ways to connect OPTEX-generated programs with the PLEX solver. If low-level, general-purpose languages are used, the appropriate way is to connect the PLEX libraries with the executables of the models. This can be done directly, or by using the Concert Technologies object libraries. If the algebraic language OPL, Optimization Programming Language from IBM, is used, the connection is direct. OPL produces an executable that connects PLEX to the mathematical models. PLEX is a high-performance solver. Since its creation in the 80s of the last century, for many decades, it has been a leader in the solver market. The library included in PLEX Optimization Studio can be linked to other optimization platforms, such as GAMS, AMPL, AIMS, and MATLAB. This makes it easier for PLEX to be used to formulate algorithms based on large-scale optimization methodologies, which significantly accelerate the time to solve highly complex mathematical problems. OPTEX generates the codes, in XML, that are required to access the databases from the specialized ODM interface. In this way, you have a starting point to fully customize the data visualization, from input to output. The display features graphics generated from ODM programs. This visualization does not require programming on the part of the user. The screen presents the display of a table from the industrial database, generated by OPTEX. The integrated product, OPTEX, PLEX Optimization Studio and Decision Optimization Center, DOC, can support the functional architecture of optimization systems across the enterprise, including modern multi-problem mathematical modeling concepts, in accordance with Industry 4.0 connectivity. program generation is done using OPTEX, which then generates all OPL programs needed to run the model using CPLEX Optimization Studio. If the modeler indicates it, or a script OPTEX, OPTEX will generate the connectivity with TM1 and IBM Planning Analytics. The program OPL is presented in parts, indicating in each case the content of the partial image. Read sets declarations and reading. SQL statements to read sets. Read parameters. Transformation of read time series parameters. From the data read in the tables, OPTEX can calculate three types of dynamic parameters: impulse, polyline, and stare. Read parameters SQL statements. Calculated parameters and calculated sets. OPTEX solves the correct order for declaring parameters, sets, variables, and constraints, considering the relationships between them. This is a common problem in other algebraic languages. Model variables declarations. Model variables bounds. Objective function variables and equations. Conditions of existence constraints. Constraints declarations and lag constraints initial conditions. Problem definition, constraints algebraic formulation, and variable existence conditions. Storing variables using SQL statements. Creating parameters to write variables results tables. Writing parameters to ODM variables graphics. Link OPTEX to IBM Planning Analytics. Some of the products offered by IBM to support solutions based on advanced predictive analytics are IBM TM1. That's IBM's OLAP database. The first step is to pass the results of the model to the TM1 cubes, and from there to IBM Planning Analytics. IBM Cognos, and IBM Planning Analytics. Connectivity to IBM Advanced Analytics can be done from any program deployed with OPTEX, such as programs in low-level languages, such as Python, Java and C++. Programs generated by OPTEX in high-level algebraic languages, such as GAMS, Mosel, AIMS, and AMPL, can also be connected. As a special case, there are the models generated with IBM PLANNIG Optimization Studio. That they can be part of the DOC environment and use facilities not available to other technologies. The diagram presents the flow of information between OPTEX and IBM Planning Analytics. Below are some screenshots of a production planning model of a brewing system. The model integrates the modeling of production and the company's financial system. The connectivity of the mathematical model is done automatically with the TM1 system, IBM Planning Analytics, without the participation of programmers or the end user. The image shows the IBM Planning Analytics System Access menu. The dashboard presents the dispatch of products from the distribution centers, CDs. The dashboard presents the final level of inventories at the end of each period. The dashboard presents the income statement, after taxes, by country. The image shows some examples of screenshots of solutions implemented with the methodologies and technologies managed by HI. Related with enterprise-wide optimization. These applications and several more are available under the HI and IBM Optimization Technologies link. Mathematical physicist Alfred Whitehead said, "Civilization advances by extending the number of important operations which we can perform without thinking of them." Thank you for your attention.